Hello Year 10 and welcome back to your next living room lessons. Now I'm just going to tell you this video might not be my best because do you know what I've just done? I just filmed this whole video and then I realised after I'd done it I had it on time lapse. So all the videos were about 8 seconds long, no sound, just me doing like this. So I'm having to do it all over again. So I'm really happy about that, but I will try and give you my best on this. And at the end, I might even give you little bloopers of me dancing around on time-lapse without realising, okay? So what we're going to be doing today is we're moving away a little bit from what we have been doing, having a look at why we get certain weather. And then the second half of this unit is having a look at different weather hazards. So having a look at how different hazards affect different parts of the world. So we're going to do a bit of a general what are weather hazards to start with today, then we're going to have a look at tropical storms. We'll spend a couple of lessons after that also looking at tropical storms, and then we have a look at drought. Now it's important that we do this because on the exam spec it specifies you need to have knowledge of two different weather hazards. One has to be a high pressure hazard, one has to be a low pressure. So we're going to start today by going through what is a high pressure hazard, what is a low pressure, and then we'll dive into tropical storms. So what you are going to need today is your exercise book, a pen and a ruler, your phone, the map of tropical storm locations, print that out small, you don't need it big, and the formation of tropical storms. So that's the kind of storyboard you'll see attached to this document. But before we do that, we will, as always, do our jog your memory. So 3 questions that I want you to do to recap what we have been doing. So name 2 air masses that affect the UK, define a rain shadow effect, and name a top-down development scheme that you have studied. So in a moment, pause your screens, scan the QR code and complete this. Just a reminder, please can we not do the silly names? We had the return of Big Juicy was back. We also had Warm Toes, I think it was as well this week. It's really, really useful for us teachers so we can see who's actually engaging with the videos. I'm sending the other teachers lists every week of who has been doing them so they can now know who to chase and who not to chase for work. So it's a good way for us to be keeping an eye on you, but without us actually having to be constantly nagging you, okay? So please pause your phones, scan the QR code and watch this for me. Okay, hopefully you've had a go at that. So as I said, today's lesson is having a look at what a weather hazard is. So we're going to start by having a look at weather hazards, what they are, and then sorting them into high and low pressure. Then we're going to have a think about tropical storms, have a think about their formation of storms. So make sure you write this title in for me, weather hazards, underline it. This is kind of the beginning of the second half of this topic. So, weather hazard is a climatic event that impacts people's lives and property. So in order for something to be a weather hazard, it has to be climatic. So it has to be caused by the climate. So we're not talking about earthquakes and volcanoes here because they're tectonic. They're not caused by the climate. We are talking about things that happen because of the climate and air pressure, etc. And in order for it to be technically a hazard, it has to have an impact on people's lives and property. So there's often this big debate about if a tropical storm occurs in the middle of the ocean, affects no one, is it a hazard? Probably not, because it's not having an impact on people. So what I'd like you to do is pause your videos and copy this key term down, highlight it so it stands out. This is an important one. Climatic event impacts people's lives and property. Okay, good. So as I said, we have to look at a high pressure hazard and a low pressure hazard. So we're just going to have a think about how you could sort a high pressure hazard. So how you could classify something that's high pressure, something that's low pressure. So we will recap, I will talk you through it again, the difference between high and low pressure. So high pressure occurs when air is sinking. And as it's sinking, it's going from a cold place in the troposphere to a warm place on the surface of the Earth. And as it sinks, it heats up and it loses its moisture, the moisture evaporates and we get really dry conditions. Remember though, high pressure is not always summer. So you get high pressure when there's clear skies, sunny days, but it isn't always hot, okay? And then low pressure is the opposite. It's when our air is rising upwards. And as it rises upwards, it goes from a warm place to a cold place. So that moisture condenses and it condenses to create clouds. Those clouds then lead to plethora of different types of weather. I have never used the word plethora before. I don't know where that came from, sorry. So what I'd like to do in your books is copy out this T-bar table with high pressure and low pressure, and then I want you to sort these different examples of weather hazards into your table. So pause your videos now and copy this out for me. Okay, so let's quickly go through these. So our high pressure events include droughts, heat waves, forest fires, and icy roads. Remember, as what I said, it's not always hot. In the winter, if there's a high pressure event, there's no clouds. So it means that it gets really, really, really cold overnight because there's no clouds kind of acting as a blanket to keep the heat in. So that's why we often get frozen roads during the winter. And our low pressure events are our hurricanes, snowstorms, thunderstorms, flooding, storm surge, landslide. Now note, all of these are events that kind of occur when there is precipitation. And precipitation we only get when there's low pressure. So hopefully you all worked that one out for me. So here is a map. So this map here, as you can see, is over the North Atlantic Ocean, over kind of North America, Central America. And this map is showing us the pathway of tropical storms. So it's showing us where they start and where they end. So the beginning of these lines is where they start, and then this is where they travel to as they are ending. Now a map like this is really, really important because it can help people to predict and track what a tropical storm is going to do. Now obviously big raging winds can't necessarily be predicted, but we can look at previous patterns and start to see where they might occur. And now this is really important because it can be used by local governments, it can be used by aid response teams, it can be used by residents, insurance companies to work out places that are likely to be affected by a tropical storm, because we can generally see that they generally start kind of to the south of our map here and they move upwards. And as they move upwards, we can see this type of places which get affected. So we can't really see because there's so many of them, but under here is our Caribbean islands. So we can see quite clearly the Caribbean islands are quite high risk of tropical storms, but we can also see that they move up to North America. What we can also see is why the UK never really gets tropical storms. We can see that we don't have to really predict for them. Insurance companies don't have to set a premium for tropical storms because it's very, very, very rare that tropical storms will make their way over to the UK. So what I'd like to do next, you all have this map on a little sheet. And what this map shows you, obviously we've got our world map here, we've got the equator, we've got our 2 tropics, and we've got our 4 different types of tropical storm. And I say different types, but that is completely wrong because they are all the same thing. Tropical storms is kind of the umbrella technical term, but in different parts of the world, they give them different names. So we can see over in the Atlantic, they're called hurricanes. These are the ones we hear about the most. In the Indian Ocean, we can see that they call them cyclones. In the North kind of East Pacific Ocean, they call them typhoons. And then the slightly funny one in Australia, they call them willy willies. Classic. So what I'd like you to do is I'll stick this in your books, but then I'd like to have a go at these 2 sentences. So tropical storms tend to start at. So having a look at where we can see the beginning of our arrows, where can we say that our tropical storms generally are starting? And then thinking about the fact I've told you that these are low pressure events, why is this? This is because, so they tend to start at, and why? Why is it they start there? So pause your screens and just make a copy of these 2 sentences for me. Okay, so hopefully you all have put that they tend to start near to the equator or between our tropics. So we can see that they are all generally starting in this part of the Earth, between our Tropic of Cancer and Capricorn. And we could say that this is because these are the places we will find low pressure. I have told you they are low pressure events, so we would expect to find them where we're going to have the most amount of low pressure. Thinking back to our global atmospheric circulation model, we know that along the equator is where we get the most low pressure. So that is why we get storms there. So what I want you to do now is bring that together and have a go at an exam question from a couple of years ago. So here is our map again, slightly different. It hasn't got willy willies on it this time. Don't know why they missed that out on the exam. But the question is, describe the location of hurricanes, cyclones and typhoons on figure 1 use map evidence only. So we're going to go through the mark scheme in a moment, but I want you to have a crack at this. So it's a 4-mark question, so you need to make 4 points. You are probably going to structure that as 1 overall, where are they? So where do we generally find them? All 3 of them across the earth. Then 1 descriptive sentence about where hurricanes are, 1 descriptive sentence about cyclones, and 1 descriptive about typhoons. Now there's a few things on the map you might want to use to help you here. Down here we've got our compass. Make sure you are giving compass points if you are saying that they are on a continent. But the other key thing is it says use map evidence only. So you should only be referring to either our equator, the tropics of Cancer and Capricorn, and the continents. There are not countries on here, so you should only be referring to continents. So pause your videos now and have a go at this question. Okay, here is our mark scheme then. So as I said, I'll talk you through this. So what it says is credit 4 valid statements, each with 1 mark. So there had to be 4 separate statements, 1 per mark. Credit the accurate use of a compass, the scale, location in relation to the lines of tropics, oceans, continents, in terms of their origin and their track. So some of the points you could have said: near the equator, mainly within the tropics, typhoons in the northern Pacific, not just Pacific, the northern Pacific, off the east coast of Asia. Cyclones in the southern Pacific and Indian Ocean, near southern Asia, Australasia, and southeastern Africa. You couldn't have just said Africa, because Africa is a massive continent and we don't get cyclones on the west coast of Africa. You needed to say eastern or southeastern. And then hurricanes in the northern western Atlantic and eastern Pacific off the coast of North America. So give yourself a mark for each one, give yourself a pat on the back and say, well done, I answered that one all on my own. So what we're going to come on to now is have a think about how they form. So what I want you to do is scan this QR code and watch this video from the Met Office. Now, a lot of my Year 11s in the past have told me that the guy on this video, he's a bit of a, he's a bit of a dunce really, but he explains it perfectly. And a lot of them have said that that's what they imagine me being like in 20 years' time, which is, I'm not sure it's a compliment really, but he does explain a tropical storm wonderfully, okay? So scan the QR code, or I have put the link there as well, and just watch it, soak it up, and then we're going to do something with it in a moment. Okay, so what I want you all to have in front of you now is your storyboard. And this storyboard talks us through the formation of tropical storms. So what we've got, there are 6 statements and 6 pictures. We're going to start with the statements. I've been kind and I've put the first 2 and the last one already in, but I've just taken out a few words. But based on what you've just seen on that video, so you might want to re-watch it while you do this, I now would like you to sort these 6 statements into the correct order on your storyboard. As you can see, I've already labelled 1, 2 and 6 because they're already on your sheets. So have a go at putting these in the correct order. All right, let's go through these. So, the first one I already had there for you. So, a tropical depression passes over water at 27 degrees or more in the tropics. This causes rapid evaporation and condensation, increasing the size of the depression to form towering thunderstorm clouds. So this is key, this bit here, that you can only get a tropical storm starting where the water is above 27 degrees. And that's quite a narrow margin. There's not a lot of the world that has got waters of 27 degrees. It is found between the tropics. If it's less than 27, you will not get a tropical storm. It has to be 27 degrees Celsius in order for you to get this evaporation and condensation, which leads to these massive thundering thunderclouds, towering thunderclouds, okay? So you need this big storm, this depression, this hot water, and this big storm in order for it to start. As that storm then rises up, you will have more warm winds blowing in and taking its space. So as it moves upwards, it sucks in more warm air. And as it sucks in that warm air, it makes our storm bigger and bigger and bigger. And when that storm then reaches winds of up to 74 miles per hour, we would then say that it is a tropical storm. In order for it to get its iconic spin shape, this is due to the fact that our Earth is rotating. And as our Earths rotate, winds don't blow in a straight line because they can't blow straight because of the curvature of the Earth. So as our Earth is rotating, and this is called the Coriolis effect, it makes our winds start to spin because they don't blow in a straight line, they blow in a spiral shape. And all of these warm winds rushing in, these thunderstorms, this low pressure, this hot water, all comes together to create our spinning vortex of doom. So this storm will pick up more and more energy, and as it picks up, as it moves across the ocean, more warm water, it gets bigger and bigger and bigger. The warm water is basically the petrol, the fuel that gets our storm going. And when that tropical storm then makes landfall, it loses its fuel. So once it hits land, it stops being able to absorb more and more water, meaning that it will very quickly lose its energy. But it might also lose its energy if the water gets colder, because cold water can't rise. So that's why we only get them in a very kind of distinct band around the Earth. So the next thing I'd like you to do, hopefully you've got those in the right order, is now you're going to add in your diagrams. So here are 6, I know, beautifully drawn diagrams because I spent about an hour doing this, making it perfect for you guys. Aren't I great? I know. And what I'd like you to do, they're not in the correct order again, so I now want you to make copies of these diagrams onto your storyboard by the correct statement, okay? So look closely at them. Some of them are quite similar, but there are subtle differences that you need to pick out. So pause your screens now and copy these out. Okay, so this is what your storyboard should look like. So here we've got our tropical depressions, we've got those warm airs rising over water of 27 degrees. This will then rise, it will lead to condensation, evaporation, and we get these clouds, these big thunder clouds. As it continues to rise, more winds blow in to take its place, and then when it reaches 74 miles per hour, that is now a tropical storm. The spin of the Earth means that our winds don't blow straight, they blow round, creating this vortex, and then when it makes landfall and hits our lovely little palm tree I drew, this is when it will then lose energy. So we can see that as it's making landfall, it's got less strong winds, there's less rainfall, because it begins to lose energy as soon as it makes landfall. So the last thing, well, nearly last thing I want you to do today is, I want us to have a think about 2 more things. So these were 2 more exam questions from that same exam paper a few years ago. And what I'd like you to do is, I'd like you to do a little heading that says, why are hurricanes seasonal? And make 2 bullet points. And then another heading, why do hurricanes lose their power? And put 2 bullet points. So I want you to think about everything we've looked at. Why do you think that they are seasonal? Why do you only get them during the summer? And then what are the reasons why they might lose their power? I just gave you 2 reasons why they might lose their power. So bullet point those underneath, have a go at that, and we'll go through the answers in a moment. Okay, let's talk through these. So, reasons why they're seasonal, because the sea has to be 27 degrees Celsius, and this only happens in summer. So they tend to only happen in summer when the sea has been heated. Now, some of you might be saying, but I thought you said along the equator that we don't have seasons, they don't have summer so much. But our tropical storms, as we know, move away from the equator, and as they move upwards towards, say, North America, they do have seasons there. So during winter, a tropical storm is not going to hit North America because their seas are too cold. And then this brings us on to the second reason, because the Earth has to be tilted in the correct way for the sun to be at a certain height. When the sun is at a certain height, this is when our seas will be heated. So this is why they are seasonal. As for why they lose their power, there are 2 main reasons. So they lose their source of heat, so they lose their heat source as the water either cools down or as it makes landfall, so they can't lift air upwards anymore, and it has no energy. This occurs often when it hits land or when it goes into cooler seas. So your 2 reasons they lose their power are as it makes landfall or as it reaches cooler oceans, okay? So the last thing we are going to do today is, I've spoilt you rotten. You have got 2 quizzes today. So what I want you to do is, again, scan this QR code, put your name in sensibly, big juicy, and I would like you to have a go at the true or false, so you can see how much you've got from this, how much you are able to kind of recap on how our tropical storms are created. Okay, good job, Year 10. So in your books, you should have our weather hazard key term, high and low pressure table, map of tropical storms, the tropical storm exam question, tropical storm formation and reasons why storms lose their power and why they are seasonal. If you haven't got all of those, go back through your video and make these notes. Again, next time you see me, we'll be having a look at the kind of causes and responses to a tropical storm, okay? So well done, good job again. I hope you're all keeping safe. Please stay in touch. I'm enjoying hearing from some of you. Some of you are sending me brilliant emails, so please keep in touch. Well done, guys.